You may remember several years ago when South Africa was awarded the hosting of the Square, or part of the Square Kilometre Array Telescope. One of the reasons was because the Northern Cape has some of the fewest radio signals in the world. And in fact, there's a large area around those telescopes that don't have cell phone reception at all, because they want to protect it from those radio signals. The equipment can't detect radio signals from stars if there are too many signals coming from Earth. Now it appears signals from Elon Musk's Starlink system may be having an impact anyway. Starlink is the system of small satellites around the world that provides internet access through a satellite link. Dr. Daniel Cunnama is the science engagement astronomer at the South African Astronomical Observatory. Dr. Cunnama, good afternoon to you. Firstly, why do radio telescopes need to have no interference? What is it that they're actually doing?
Good afternoon. You'll be familiar with optical telescopes, and that these are the traditional telescopes that we think of, and we have light pollution. So if you have an optical telescope, you want somewhere very, very dark. You don't want a car driving by with its headlights. You don't want a street light, so that you have a nice dark sky so you can see the stars, see the light from the stars clearly. It's exactly the same with a radio telescope. So radio waves are just a form of light. And we're observing that with a radio telescope. And if we have radio pollution, light pollution, then that affects our ability to observe the radio waves.
So then a cell phone tower would produce a huge amount of radio light, if you like.
For sure. So, a radio tower, a cell phone tower, TV, even cars, petrol vehicles, your cell phone, your Bluetooth, they're all like somebody shining a torch or a very bright light or floodlight into a radio telescope.
Okay, so then what's happening with the Starlink system? Why suddenly is it having this impact on the SKA?
So the Starlink system, at the moment there are about 5,000 Starlink satellites up there, which is already a huge amount, and over the next decade I think it's going to get to about 40,000. So they're a network of satellites. At any given time, you'll have tens of them above you, and what they're doing is providing very high-speed internet. And at the moment, they're operational and doing an excellent job at doing that. But in order to do that, they need to transmit radio waves, and that's how they're sharing the internet, and that's how they're communicating with Earth. And what that means for us is that there are many, many more satellites in space than there were a few years ago. And that makes it a very, very noisy place to try and observe with a radio telescope. And, this is something which there have been efforts to mitigate already. There are certain bands of the radio spectrum which are allowed for communication, and that's where, radio telescopes will just delete the data. We'll work in the other bands that aren't dedicated to communications. But the recent paper, the recent discovery that some of these Starlink satellites were leaking radio waves into different bands. So they were emitting in bands which, not intentionally I don't think, but emitting in bands which were dedicated to radio astronomy.
I suppose, can the Starlink satellites, the new ones, the ones already up there, be stopped from doing this? Sometimes it can just, what these things are like. Sometimes it can be a software tweak. Sometimes you're actually going to have to switch the whole thing off.
So in this particular case, it seems like it is one of the electronics systems on the Starlink, which is emitting in a radio band which they didn't, expect. I think that it's also a testament to the sensitivity of these telescopes. They're picking up very, very faint objects from the distant universe. So if there's a slightest signal coming from an instrument or an electronic circuit on a radio, on a satellite in space, we can pick that up. But yeah, so the ones that are up there, it sounds like in this case, it may be a bit of a problem, but again, like I said, we have been working with Starlink in the past. They have been very helpful in terms of, they're firstly in the optical regime. The first Starlink satellites that went up were very bright. After astronomers complained, the newer ones are a lot less reflective, so they're much harder to see. So that was a huge improvement. For the SKA sites, there is actually an agreement that Starlink will turn off its service as the satellites pass over. So there will be a gap in service there. You won't even be able to get Starlink. But But as I said, if there's still some instruments which are emitting, we're still going to be able to see something.
Dr. Cunnama, was this all foreseeable? I mean, I remember so clearly how so many precautions were taken to avoid sort of, radio transmissions in the Northern Cape. Digital terrestrial television was switched off there first, just for this reason. Did we know that this would happen when the Starlink satellites first went up? And when there must be other satellites that aren't Starlink that are up in the same space of sky?
Yeah, so I think that we always knew, there's satellites that have been up now for generations, and we knew that this was going to be a problem for radio telescopes. But as I said, we can put certain bands aside for radio communications, which then we don't get to observe in, and that's okay. It's like a certain color you can't see, or a very specific shade of red, for example, that you just can't see. And that's okay, we can live with that. But I think that in the last decade, and I think that this wasn't foreseen on this scale, when SKA was planned and approved and started to be built, I don't think we realized the scale of these satellite constellations that were going up. I don't think anybody did 10 years ago. It was a very novel invention. I don't think we believed that this was going to be quite possible. But the rate of technological advancement that we're seeing these days is very hard to keep up with.
I would presume the future of radio astronomy is actually in the space. If you can get all of the equipment up there, you would then have it on a satellite, I suppose quite a big satellite, maybe quite an expensive one, beyond where the Starlink satellites are, right?
It's an excellent idea, and we have thought of it. The best place is actually the dark side of the moon. So that's where we're aiming, and maybe in 50 years we'll have a huge radio telescope on the far side of the moon. And then all of the radio waves that are coming off Earth, or from every angle and every satellite and every tower, will be blocked by the moon.
You may want to avoid watching Transformers 2. What kind of research are we actually getting from the SKA at the moment? What kind of science are we seeing from it?
So the SKA will go online in the next few years. At the moment, Meerkat is the premier radio telescope, and that's a South African project, 64-dish array. And that already is the most powerful radio telescope in the world, and the discoveries are coming thick and fast. There's something new coming out of Meerkat every week, and we're looking on various scales. So we're looking from individual stars, we're looking at spinning neutron stars and pulsars, looking at gravitational waves, and then also looking right back to the beginning of the universe. So the first stars and galaxies, and how the gas and dust have formed into stars and galaxies over the billions of years of our universe's evolution. So it's a very diversity widely usable telescope. It's not focused on one particular science. It's able to be used for a lot of different science questions, and it's been very exciting so far. And I think the SKA will just push it that much further.
Well, I was going to say, I presume the SKA will take us where no one's gone before.
Absolutely. I think that, we're seeing it with JWST, the James Webb Space Telescope at the moment. This was a huge leap technologically from Hubble 30 years ago to this now. And again, we're seeing incredible science coming out of it, things we didn't expect at all. And I think that that's the most exciting part of these things. The SKA is almost certain to raise questions and answers which we didn't even think of.
Dr. Daniel Cunnama, thank you. Science engagement astronomer at the South African Astronomical Observatory.